Now, as the world becomes increasingly digitalized, the insurance industry is on the cusp of a profound transformation. But with the power of AI image synthesis at its fingertips, insurance companies can revolutionize the way they access risk, streamline processes, and improve decision making. So, today we will explore the cutting edge technologies of vision transformers, stable diffusion, and generative adversarial networks and their potential to reshape the future of insurance. So let's get started with vision transformer first. Now this vision transformer is a type of neural network architecture used for image classification task. And it is based on the transformer architecture which was originally designed for natural language processing tasks such as machine translation. So in simple terms, a vision transformer processes image by breaking them down into patches similar to how a language model or the language transformer will process words in a sentence. And these patches are then converted into a sequence of vectors which are fed into the transformer's multi-head self-attention mechanism. Now this mechanism allows the model to understand the relation between different parts of the image and make predictions about the image content. Now an example of how the vision transformer can be used in the insurance domain is in the field of claim processing. For instance, an insurance company may use a vision transformer to automatically analyze damage to a vehicle involved in an accident. The transformer could be trained on a large data set of images of a damaged vehicles and their corresponding repair estimates. So whenever a new image is presented to the transformer, it would predict the necessary repairs and the associated cost. And this could potentially streamline the claim process and reduce the time and efforts required for manual damage assessment. So to summarize this, we can say a vision transformer is a type of neural network that uses the transformer architecture to analyze images, and in the insurance domain, it can be used for tasks such as claim processing by analyzing images of damaged vehicle and making predictions about necessary repairs and cost. Now next comes stable diffusion. Now this stable diffusion model is a type of generative AI model that generates new data by iteratively transforming a random noise vector into coherent and plausible output. In the context of insurance, it could be used to generate realistic images of damaged vehicles or to predict the likelihood of a claim being fraudulent based on the text in an insurance application. For example, let us say an insurance company wants to use stable diffusion model to generate images of a damaged vehicle for use in their claim processing system. The model would be trained on a large data set of images of damaged vehicle and their corresponding repair estimates. The process of generating a new image using a stable diffusion would work as follows. First, a random noise vector is generated, which is a series of random numbers that serve as the starting point for the generative process. Then the noise vector is transformed into the initial image by applying a series of mathematical operations. This step is designed to create a rough approximation of the damaged vehicle, but it may not be fully coherent or realistic. Then the model is used to predict how the image should be transformed at each step based on the patterns it has learned from the training data. This iterative process gradually refines the image, making it more detailed and coherent. Then the final output is a realistic image of a damaged vehicle, which could be used in the claim processing system to streamline the damage assessment process. So by using a stable diffusion model, the insurance company can generate new images of a damaged vehicles on demand without having to rely on the fixed set of images. And this can be particularly useful in situations where the company needs to access damage for a vehicle that is not in their existing data set. So to summarize this, we can say a stable diffusion model is a generative AI model that generates new data by iteratively transforming a random noise vector into a coherent and plausible output. And in the insurance domain, it can be used to generate images of a damaged vehicle for use in claim processing, streamlining the assessment process, and potentially reducing the time and efforts required for manual assessment. Next comes GANs or generative adversarial networks. Now these generative adversarial networks are a type of deep learning model that generate new data by training two neural networks to compete against each other. These GANs have a variety of applications including the insurance domain, where it can be used for tasks such as detecting fraudulent claims or generating insurance policies. So in a GAN, there are two neural networks, a generator and a discriminator. The generator's job is to create new data that resemble the training data, while the discriminator's job is to distinguish between the real data from this training set and the generated data from the generator. So to understand this better, let us consider a simple example in the insurance domain, that the generator network is trained on a data set of insurance policies. It learns to create new policies that resemble the policies in the training set. And the discriminator network is also trained on the same data set. Its goal is to distinguish between the real insurance policies and the generated policies. So during the training process, the generator and discriminator network compete against each other. The generator tries to produce convincing policies that the discriminator cannot tell apart from the real policies, while the discriminator tries to accurately identify real and generated policies. And over time, the generator improves its ability to produce high quality realistic insurance policies, while the discriminator becomes better at recognizing generated policies. And by training GANs on the large data set of insurance policies, insurers can generate new policies tailored to their specific needs and custom requirement. And this can be especially useful for generating policies for customers who require customized coverage, or for creating new policies in a language that is easily understandable for non-technical customers. So to summarize this, we can say that these generative adversarial networks are a type of deep learning models that generate new data by training two neural networks to compete against each other. And in the insurance domain, they can be used for tasks such as generating insurance policies tailored to specific customer needs and requirements. Thank you.